Alright class, today we're going to be counting outcomes. For probability, outcome is anything that can result from an experiment or an event. We're going to count all the possible outcomes of what I call compound events. More than one thing is going to be happening. Okay, if I roll a dice, we know there's only 6 outcomes. But if I roll a dice and flip a coin, how many outcomes are there? Or if I roll 2 dice or 3 dice, lots of possibilities. So when I am counting outcomes, it's sometimes helpful to draw a tree diagram. Okay, it's sometimes time consuming, but it's better to be right than wrong. So let's look at this one here. How many different fish tanks can be made from 3 size choices and 2 shapes? All right. So a tree diagram, you start off by making branches to the first option. There's 3 sizes. There's small, medium, large. So a branch to small, a branch to medium, and a branch to large. Off of those branches, there's 2 shapes. You can have pentagon or a rectangle. All right. So I can have a small with a pentagon or a small with a rectangle. I can have medium with a pentagon, medium rectangle, and then large pentagon, large rectangle. So this tells me this final branch or series of branches here tells me how many possible outcomes there are right here. Okay, so here I just said that small pentagon, small rectangle, etc. There's 6 possible outcomes for this fish tank. All right. Now you're probably already noticing a pattern here, but we'll get to that shortly. But let's just write it down. How many sizes were there? There's 3 sizes, and there was 2 shapes, and the answer was 6. So keep that in mind as we move on here. All right, I'm going to draw a tree diagram to find the number of different outfits that can be assembled using 5 shirts and 4 pants. So if it tells you to do a tree diagram, you have to do it. All right. You might know the final answer, how many outcomes are, but you have to draw it if it asks for one. All right, so I have 5 shirts. So I'm going to have 5 branches going to my shirts. Shirt red, a red shirt, a white shirt, a green shirt, a blue shirt, and an orange shirt. And then there's 4 pairs of pants. So each shirt can have 4 different pants with it. So I make 4 branches from this one. I make 4 branches from this one. I'm doing this with my mouse, so keep in mind it's going to be a little sloppy. 4 branches from G, running out of room. 4 branches from B, this is ugly. And 4 branches from orange here. Alright? Anyway, I might have different pants. I have sweatpants. Might have yoga pants. Might have dress pants. It might have blue jeans. Something like that. And you have that for every single option. So how many outcomes total are there? Well, there's 4, 4, 4, 4, 4. Total of 20 outcomes. Alright, so here's what maybe a little better drawn one would look like. Here's shirt 1 through 5, pants 1 through 4, total of 20 outfits. Alright, so that's how we count. And again, keep in mind, 5 and 4, my answer is 20. How did I get there? Well, here it is. Counting principle. The fundamental counting principle is if event M can occur in so many ways and another event can occur in a different number of ways, you're going to multiply those numbers together. Alright, so example, we had the fish tank. This one says 4 sizes and 3 shapes, so 4 times 3 is 12 possibilities. Alright, example 2 here. You got a pizza shop. I did this for Subway once. I counted how many different possible subs you can get, different types of bread, different types of meat, different types of cheese, different types of sauces, different types of toppings. There's a huge number because you have to multiply all those possibilities together. For here, we'll keep it simple. A pizza shop has a regular, a deep dish, and thin crust. It has 2 cheeses and 5 toppings. All right. So how many different crust types are there? Well, 3. How many cheeses? 2. How many toppings? 5. I multiply them together. There's 30 different pizzas that you can make. Alright, 3 times 2 times 5 is 30. 30 different possible pizzas. Right here, to get to her locker, Shelly can walk through 4 different doors, 4 different stairs, and 3 different hallways. How many ways to get to her locker? Well, without drawing a tree diagram, I'm going to do 4 times 3, which I believe is 48. Let's check it out. Boom, 48 ways. Okay, so counting principles are not that difficult. We're multiplying all the possibilities. But if you ask for a tree diagram, you have to draw the tree diagram. Okay, so here they drew a tree diagram, which I didn't think was necessarily that helpful. We can kind of count through these possibilities. But you have 2 counters that you're going to throw in the air. One has an E on it, the other one has a J. Okay? If you throw both of them in the air and they land one E and one J, then Emilio wins. Otherwise, Jacob wins. So Jacob wins if they're the same letter, E and E or J and J. So what's the probability that Emilio wins? Well, they drew it out for us here. But again, you're doing 2 counters with 2 possibilities. 2 times 2 is 4 possible outcomes. Now the tree is helpful here because we need to see how many actually are what we want. Okay? Remember, probability is what we want over the total number. So 4 is my total number of outcomes, so that's my bottom number. Okay? And I want to count how many on this tree diagram give me Emilio winning, meaning 1 is E and 1 is J. Well, E and E, that's not a win. There's a win. That's not a win. Oh, that is a win, sorry. That is a win. And that's not a win. So 2 possibilities win. So 2 out of 4 times we expect Emilio to win, which is 1/2, which is 50%. Alright. What's the probability of randomly choosing a 5-letter password that consists only of vowels if each vowel can be used more than once? Here's a guided practice for you to try. I'll show you the answer, see if you can get it. Pause it if you want to try it on your own. 5, 4, 3, 2, 1. And here's the answer. Boom. 1 out of 3,125. Okay. So you got 5 letters, 5 are vowels. 5 times 5 times 5 times 5. 1 out of 3,125. Last problem. Here we go. We have 2 spinners. What is the probability that the spinner will be red and the number 9? So we're spinning both of these. How many outcomes are there on this colored spinner? Well, 1, 2, 3, 4, 5. 5 outcomes. How many outcomes over here? 10 numbers. Now I can draw a tree if I want to. 5 branches to the colors, then 10 numbers coming off of each color. Or I can just do 5 times 10, so I know there's 50 outcomes. Alright? And how many of those outcomes are red with the number 9? Okay? Well, if you drew a tree diagram, you just go to the end and find where the red 9 is. There's only going to be one of them. Or, you think through it. There's a red and there's a 9. If there's another 9 somewhere, that might change it. But there's only one outcome that's a red 9, so it's 1 out of 50, which is 2%. Alright? Good, great, grand, super. That's counting outcomes, not too bad. Biggest thing is to multiply. And drawing a tree diagram can help kind of stay organized. Again, it's better to be right and do it the long way than wrong and try and do a shortcut. But if you trust yourself and you know how to count the outcomes properly, this shouldn't be too difficult of section for you. Alright? Have a wonderful, wonderful day of school.